A, B, C, or D. And that's how I'll know what your guys' answers are. So 1.1 says, which one of the following is a structural formula for the functional group of the ketones? So all I want you to do is post A, B, C, or D in the chat. I'm going to give you guys 2 minutes. Thanks, Wandile, for your quick fingers. Thanks, Khalalelo and Logical, for your quick fingers there. Okay, everyone else, take your time, go through the question thoroughly, make sure you understand what's there, and then you can give me your answers. And then at the end of the session that I give you the 2 minutes, I will go through the correct answer with you guys, so don't panic. Okay, and then to save you guys some data, I'm gonna switch my video off just for the rest of the lesson, and I'll put it back on right at the end of the session as well. Okay, thank you for all the engagement. I'm getting lots of C's. And then let's look at the TikTok group, lots and lots of C's. And then there's an A in there as well. Okay, now when we look at this, what will our correct answer be? Our correct answer will be C, right? Remember, so your ketone is going to be that group that has the O in the middle. Think of the word ketone, right? If you look at the word ketone, apologies for that, my screen just went off. If you look at the word ketone, it's got that O right in the middle, and that must always be your clue when you think of ketones. Not like aldehydes. Aldehydes have them at the very end, so you'll see B would be an aldehyde, A will probably be an aldehyde as well. D is going to be an alcohol, so C becomes our correct answer there. If you got that right, give yourselves a round of applause in the chat, or a fire emoji, whichever way you can celebrate yourselves. But don't panic if you didn't get it right. We're going to have lots of other questions. The only people that must panic are the ones that didn't give an answer at all. Remember, guys, rule number 1, never leave multiple choice blank, right? If you leave it blank, you have a 100% chance of getting it wrong. If you guess, you've got a 25% chance of getting it right. Okay, so never leave it blank. For the next question, I want you guys to all engage and all give the answer that you think is correct. Okay, let's look at 1.2. 1.2 says, which one of the formulae below represents an alkane, right? Alkane. Which one, A, B, C, or D? Which one of them will be an alkane? Thanks for the quick fingers there. Okay, getting some B's, some C's, some D's. There's some B, there's some C. Let's see how everyone's going through this one, right? Which one is going to represent the alkane? Okay. Just before I give you guys the correct answer, I'm going to quickly remind you of the general formula for alkanes. The general formula for alkanes is going to be what? It's going to be CnH2n plus 2. So you must have however many carbons you've got, the hydrogens must be double plus 2, right? And in this case here, you can clearly see that the correct answer for that is going to be C, where I've got 14 carbons, and then my hydrogens are going to be 14 times 2 plus 2, which gives me 28 plus 2, which gives me 30. So that is the correct answer. C, if you got C as the correct answer, give yourselves a round of applause. If not, don't panic. You've got a couple more questions to redeem yourselves, right? Awesome. Okay, let's look at 1.3 together quickly. 1.3 says, consider the organic compound below, and they give us the structural formula. The IUPAC name of this compound is, and they give us 4 options: 2,3-dimethylbutane, 3,3-dimethylbutane, 2,2-dimethylbutane, or 1,1,1-trimethylpropane. I'll give you guys 2 minutes quickly to have a look at what the answer for this one is going to be. Thanks to Wandile and Teboho there for their quick fingers. Rabauna as well. Thank you so much. Thanks, Jerry, for your guys' quick fingers. You guys are really interactive. I really like it, guys. Thank you so much. Really appreciate you guys. Okay. If you already answered your question and you're on TikTok and you haven't followed us, or you're on Zoom and you haven't followed us, please follow us. We're trying to get to 20,000 followers on Zoom by the end of the year. Any little follow is really going to help. It's gonna help us get to our goal. I think we're on like 13,000 for now. Okay. So thank you as well to Linda for liking our live. You guys are awesome, man. Okay, 10 more seconds, and then we can look at the answer. 5, 4, 3, 2, and 1. Okay, so let's quickly have a look at how we're going to find the IUPAC name of this compound. So remember, the first thing to do is we must find our longest chain, right? And the trick they wanted to catch you out on was they wanted to catch you out thinking that you're going to have this as your main chain with 3 methyl groups. If you got that, then they managed to trick you quite well. What we need to do now on our side here is we need to say, well, actually, I can go even further. So I can even go one more carbon like this there, right? Or you could even have gone one carbon up or one carbon down. It doesn't matter. But the key thing there is to realize that we're dealing with 4 carbons in our longest chain. So immediately there, I know that D is not my answer. It's not propane. It must be a butane. Okay, and then we start numbering our carbons. So remember, we number our carbons from the one closest to our functional group or closest to our side chains. And in that case there, it's going to be carbon 1, 2, 3, and 4. So already we know there that at that point there, I've got 2 methyl groups. Where are my 2 methyl groups? I've got one that's sitting right here, and I've got another one that's sitting right there. Both of my methyl groups are sitting on my carbon number 2, if you guys can see that. So I'm going to have a 2,2-dimethyl butane, meaning B is not going to be the right answer. Neither is A. Our correct answer in this case is going to be C. If you got that as your right answer, give yourselves a great round of applause or a fire emoji in the chat. If not, don't panic. There's lots more questions for you to redeem yourself. Okay. Thank you, Tebo, for following us. We really appreciate it there. And thank you for sending us a rose and a gift on TikTok. Appreciate you. Okay, let's go down to number 1.4. Right. 1.4 says the activation energy can best be described as the minimum energy required to do what? A, cause effective collisions. B, make reactant molecules collide. C, change the orientation of reactant molecules. Or D, increase the kinetic energy of reactant molecules. I'll give you guys 2 minutes quickly to do 1.4. Remember, just put your answers in the chat, A, B, C, or D. Thank you guys so much for doing that. Really appreciate it. Thank you, Nomfundo, for following. Thank you, Egyptian. Thank you, Muteo and Butelezi for following. You guys are really awesome. Thanks, man. And thank you for sharing the live, Kabelo. Yeah, really, really awesome. Egyptian, thanks for your quick fingers there, as well as dark-skinned, as well as Ishmael. You guys are really quick there. Godfrey and Rafil as well. Thank you so much. 30 seconds for everyone else who hasn't picked the right answer. Remember, guys, don't panic, don't speed. Read it carefully, take your time, and you'll be able to get the right answer. Okay, I'll give you guys 10 more seconds. Thank you, Snare, for following, as well as KK. Okay, 5, 4, 3, 2, and 1. So 1.4, the correct answer in this case is going to be A. Why? Again, activation energy can be best described as the minimum energy required to cause effective collisions. Remember, effective collisions is when our reaction starts to take place. When bonds get broken, then new bonds can be formed, right? The answer will not be B, to make reactant molecules collide. Activation energy isn't required to make those collide, right? Activation is when you get your reaction going. The reactant molecules will collide anyway. Remember, the kinetic theory of matter states that, all matter is always in motion. So that'll happen regardless of whether you've reached activation energy or not. They will still collide. What's important is, are the collisions effective or not? C, change the orientation of the reactant molecules. Nope, it won't do that. Activation energy is not really going to help the orientation. Things that help orientation are like your surface area, things like that, your increased concentration, and then also increase the kinetic energy of the reactant molecules. Again, it doesn't do that. Remember, your activation energy is simply the amount of energy required for it to happen. So it won't increase the kinetic energy of the reactant molecules either. A is the right answer, and all of these other ones are not. If you are joining us for the first time again, guys, I take this process quite seriously, especially the multiple choice process. And I always show you why one answer is correct and why the other ones are incorrect, because it's very useful for yourselves in your exams to take yourself through that process, right? To then say, this is why I think this is right. This is why I think this is wrong. And then convince yourself exactly what the final answer is going to be. I see some of us are already going to 1.5 already, being very, very, very quick there. Thank you very much, Nomfundo and Mpumen Palisa for jumping in there. Whitney, thank you for following us. Let's jump to 1.5. So 1.5 says, which statement is correct for a system in dynamic equilibrium?
Ernest.
Hey, Theo.
Sorry, before you proceed, there's a question from Alpheus there.
Sorry, let me quickly try and find, is it in the Q&A or in the chat?
In the chat.
Sorry, there's a lot of messages coming in.
It's a long one there.
Okay, I'm looking for the question. I'm not finding it. 622.
Yes.
622. There's no question I can see at 622 in the chat.
Oh, it was sent to host and panelist only. Let me post it in there.
Oh, thank you very much. Okay, thank you. Okay. So, evening, sir, what happens when a molecule isn't an alkane, but something else? Does that mean that we'll always count our carbon atom chain, including whatever functional group there is in it? So yes, 100%, right? Whenever you are counting your carbons, right, you count every single carbon in that case there. So it doesn't matter what's attached to that carbon, you will count every carbon in that longest possible chain. And that's very important. As long as the carbons are connected in one straight line, even if the line changes and bends left and right, just find your longest connected line of carbons, and that's how you'll basically get there. Thank you for a question. That's a very good question. Really appreciate it. Okay, thanks Itu for following us there. Really appreciate it. Let's jump to 1.5. Which statement is correct for a system in dynamic equilibrium? Okay, either A, all reactants are used up. B, the forward reaction is equal to the reverse reaction. C, all substances in the reaction are of equal concentration. D, the concentration of the reactants and products remain constant. 1.5, quickly give us your answers in the chat, guys. Thank you for all the quick fingers there. Thank you for Poshi for following us and Lesedi for sharing the live. Share the love, guys. If you've got a friend that you know should be in the session, or a friend who you know is going to benefit from this, or a WhatsApp group with your friends that's going to benefit there, please share the TikTok live link, just so that we can, share the love, make sure everyone can pass, everyone can do well, man. I want you guys to do so well. Okay. Give you guys 10 more seconds for 1.5, and then we'll look at the answer together. Five, 4, 3, 2, and 1. All right. So for 1.5, which one is going to be the right one? Which statement is correct for a system in dynamic equilibrium? All reactants are used up. The forward reaction is equal to the reverse reaction. All substances in the reaction are of equal concentration. The concentration of the reactants and products remain constant. Okay. This one is a little bit of a tricky one, and you guys might fight me, but I'll explain why. So the answer for 1.5 is D. Right? Answer for 1.5 is D. I know a lot of you think the answer is B, but I'll show you why I would say it's not B. Now, B says the forward reaction is equal to the reverse reaction. Now remember, saying the forward reaction is equal to the reverse reaction, it means the reaction does the same thing. For dynamic equilibrium, it's the rate of the forward reaction that must be equal to the rate of the reverse reaction, not that the forward reaction and the reverse reaction are the same. The rates must be equal. That's why it cannot be B in that case there. And then again, A, all the reactants are used up. No, they're not. We're making up reactants as quickly as we're making products. All substances in the reaction are of equal concentration. No, that's not true either. The concentrations don't have to be equal, but the reaction rates must be equal. I hope I say your name right. Kesson said, yeah, they don't say rate. Well done. This is very, very, very important. Debo was asking, isn't the chemical equilibrium the same as dynamic equilibrium? Right? So chemical equilibrium is sort of the name, the overarching name for what we are doing in the topic. So the specific term there is dynamic equilibrium, right? Chemical equilibrium is what we call the topic, what we call the whole process that happens in that case there. Okay, hope that makes sense to you, Deborah. All right, let's quickly jump into number 1.6. And 1.6 is going to be as follows. 1.6 says, initially, a certain amount of P, right, which is a gas, was placed in an empty container. The hypothetical reaction reaches equilibrium in a closed container according to the following balanced equation. Then we can see our equation there. So I'm going to try to get this to the right size so that everyone can see it. There we go. So we can see there that P becomes 2Q in a reversible reaction. Which graph below best illustrates the resulting changes in the rates of the forward and reverse reactions after the temperature of this reaction is increased? So we've got P becoming 2Q, and then what you want to see again is that at time T, the temperature is increased. Which graph below best illustrates the resulting changes in the rates of the forward and reverse reactions after the temperature is increased? Again, if you are new and you've joined us more recently, please just look at the question, take your time to go through it, and then just give A, B, C, or D in the chat as your answer. Okay, thank you for everyone who shared the live. Really, really awesome of you guys. Toriso's got a hand up. I don't know, Theo, if you can help Toriso unmute. Remember, guys, academic questions only. If it's to do with the logistics of the class, we won't be fielding those questions.
I don't see the hand, Ernest.
Maybe it went away. There was a hand up from Toriso, but I think maybe it went away. Okay, I'll give you guys one more minute to have a look at this problem. Which graph A, B, C, or D best describes the resulting changes in the rates of the forward and reverse reactions after the temperature is increased? Okay, almost ready to do the correction. Please make sure you submit your answer as soon as you can. 10 seconds to go. Quickly put your answers in. 5, 4, 3, 2, and 1. All right, so the answer for 1.6 is B. If you got it right, give yourselves a round of applause. If not, don't panic. There's more questions for you to do. Let's look at why B is the correct answer, right? So B is the correct answer. So now let's think about what happens here. When we look at these graphs, I'm going to just try zoom into one graph as it is there, right? The first thing we need to identify, right, is we were told that a certain amount of P was placed in an empty container. So we know that if we start with P in the container, the reaction that must start first is our forward reaction. Because at the beginning of our sort of T is equal to 0, we have all reactants and no products. So our forward reaction is the only one that can take place. And as we produce products, we can start having the reverse reaction take place over time, and it'll increase its rate of reaction until we reach our first equilibrium. So the very important thing to see there is now we have our forward reaction. I'm going to put that in green this way, the dotted line. And our reverse reaction, I'll put in orange, the solid line. That's solid line is our reverse reaction. So we hit equilibrium somewhere around here. We hit chemical equilibrium. At T, we have a disturbance. The first thing we now see is that the reverse reaction is favored. Let's quickly go back and also look at our reaction. Very important facts that were given to us is the fact that this reaction, delta H is negative, which means we're dealing with an exothermic reaction. Now, when temperature is increased, Le Chatelier's principle states that the system will favor the reaction that will counteract that disturbance, right? So if temperature increases, the system wants to decrease the temperature by favoring the endothermic reaction, which is what's going to absorb our temperature, right? So the endothermic reaction is our solid line. So that is the one that has to spike initially. So initially, what we're looking at there, the solid line has to spike because that is our reverse reaction. That's how we can immediately know that A cannot be the answer, because in A, the forward reaction is favored. C cannot be the answer because for C, the forward reaction was favored, right? And then why it can't be D, no reaction is favored. All that happened is that the rates both went up together. So D represents an example of if I were to add a catalyst at time is equal to T. So D can't be the answer. So the one that shows us that the reverse reaction is favored is going to be B. A, C, and D are not the right answer. Hope that makes sense to you guys. If there's no further questions, I'm going to jump straight to 1.7. Theo, just give me a shout if there are questions. I seem not to be able to see them on my side. No. Can I move on? Okay, Umpemet has got a hand raised. I don't know if the hand is still raised.
It's not there anymore.
Oh, okay. Sorry, guys. If you do want to speak, please keep your hand raised, and then we'll allow you to unmute and speak in the session. Okay. Awesome there. Thanks, Naomi, for following us. Someone does have a question there for us on TikTok. Which one is the reverse on the graph? Sorry, I joined late. I'll quickly show you here. So in this case here, they told us that we started off with P placed into an empty container, meaning our P is going to be our reactant. Our forward reaction has to take place first. So we can see, right, that our forward reaction is going to be the dotted line, which means the reverse reaction is going to be our solid line, the one that starts at 0 and then goes that way. So the one that has our solid line spiking is going to be the correct one in that case there. Hope that makes sense. Right. Then 1.7 says, okay, 1.7, we've got the reactants 1 and 2 below have equilibrium constant Kc greater than 1, right? Then you've got a reaction 1, you've got a reaction 2. Based on the reactions above, the acids, in order of increasing strength, weakest to strongest are, and then they'll give you the H3X, H2X minus, H3O plus. You guys must decide what is going to be your acids in terms of increasing strength. Go for it. I'll give you guys 2 minutes to quickly look at that one. Just remember, once you have done it and you're comfortable with your answer, just post it in the chat. Thank you, Mapula, for following us. We really appreciate it. And thanks to Emmanuel for sharing the live. Guys, share the love. And Deboho with the quick fingers has already dropped in their answer. Thanks, Zuel, for following. Really appreciate it. Okay. Guys, remember, look at 1.7. Take your time with it. Don't panic. Don't stress. And then put your answer in the chat as soon as you're ready. Okay, 30 more seconds, guys. Then we can look at the answer together. Thanks, Deborah, there for more gifts. Really appreciate it. Okay, 10 seconds to go. 5, 4, 3, 2, 1. Okay, let's have a look at this question together and basically figure out how to know what's happening. So a lot of information is given at the beginning. We have two reactions. These are now acid-base reactions, and we've been given Kc values that we were told are greater than 1, right? Remember, with your Kc value, it tells you roughly the extent of your reaction, right? So a low Kc value means you've only created very few products. A Kc value of 1 is going to be basically half products, half reactants. A Kc value of bigger than 1 means you've got mostly products. You've converted most of your things to products. Now, when we're dealing with acids and bases, what that Kc value means, think of it like a Ka value, right? It means that in this case, our acid ionized nearly completely. It ionized quite far. So the acids that we've got there are going to be strong acids. So the first way to figure this out is we're going to find the two acids. So in reaction 1, we can clearly see there that we're going to have H3X, and we're going to have H2X, right? Let's track what happened to the species. So H3X becomes H2X minus, right? If H3X becomes H2X minus, then we know that H3X gave off a proton, meaning H3X is one of our acids, right? So H3X is definitely going to be one of our acids there. Let's look at reaction number 2. We've got H3O plus, which becomes H2O, and H2X minus becomes H3X. So then again, there we're going to have H3O plus giving off a hydrogen to become H2O. Very important there. So already in that case there, we know that our first two strong acids, right, are going to become H3X and H3O plus. Now, what we need to do is we need to find, right, the next strong acid that we're going to be dealing with in that case there, and then that will be able to help us find it. So one thing I want you guys to remember is we have now acids and bases, right? If you've got a base that's going to be slightly weak, right, the conjugate of a weak base is going to be a strong acid. That's quite important to remember. So the conjugate of a weak base is going to become a strong acid. So when I'm looking now at these particular cases there, we can see that between our HCO3 minus and H2X minus, right? HC3O minus versus H2X minus, HC3O minus in that case there has less hydrogens, right, to give. Please note that, right? So we've got a polyprotic. If H2X minus were to be an acid, because we can tell that H2X minus in this case is going to be an ampholyte, but it's got more hydrogens to give in this case, which means it's going to produce way more products than HCO3 minus, right? So if HCO3 minus is going to be the weaker acid of the two if they were to become acids because they are both ampholytes. If it's the weaker acid, it means then its conjugate there is going to be fairly strong, which is going to be this H2CO3. So in that case, now we've identified that we're going to have, let me erase these two, right? I'm looking at my initial acids. So we've got H3X, we've got H3O plus, and we've got H2CO3 as what I would see in this reaction here being the strongest of the acids. Two of my acids are going to be strong because they're going to be my main acids. The other one is going to be my conjugate acid that was created by my base reacting on the other side, right? So those are the three that are going to be there. And then how we can basically put those three together. I know that H3O plus is probably going to be the weakest of those three in that case there. After H3O plus, we'll then have H3X, which is going to be sort of slightly stronger. Sorry, apologies there. So we'll have H3X, which is going to be right in the middle of them there. And then we're going to have H2CO3 as the one that's going to be quite weak because it isn't traditionally like a strong acid. It was just strong because it came from a weak base. Okay, so I'm not going to spend too much time on this. You'll see as we go through acids and bases, especially doing the hydrolysis of salt solutions, we're going to go through a lot of this understanding and unpacking. Strong acids will create, weak conjugate bases. Weak bases will create strong conjugate acids, and you guys will see that a little bit better. So in this case here, it's going to be B that is going to be our correct answer there, from weakest to strongest, where the weak one is going to be our conjugate that came on the other side, and the strong ones are going to be the two that we started off with in the beginning. Okay, hope that makes sense. I'm not going to go too deep into this right now, just because we need to start our contextual questions, but keep that in mind. If you can't remember this, we do have a recording where we did a whole acids and bases lesson on our YouTube. Go to our YouTube and watch that whole lesson where I go into the details of weak acids create strong conjugate bases. Weak bases create strong conjugate acids. And then you'll understand this part a little bit better. Okay, let's jump down to 1.8. If you guys got the right answer, by the way, round of applause. If you didn't, don't panic. There's still 2 questions to come. All right, 1.8 says, consider the cell notation for a galvanic cell below, where we can see there, we have a nickel half cell and a hydrogen half cell. Which one of the following is the half reaction that takes place at the anode of the cell? This is a nice and easy one. I'll give you guys 1 minute, 30 seconds to do 1.8. If you've just joined us, we're doing multiple choice questions. We're on 1.8. Please, what you need to just do is post down the A, B, C, or D, which one you think is the correct answer, and then we will come back and do the corrections together. Taviseng asks, what's your YouTube channel? Just go to YouTube and search the Learning Space ZA, and then you will find our YouTube channel there where we posted it. Or if you go to the learningspace.co.za, go to live class, and you'll find recordings, previous recordings of the sessions we have run. That's where you can also find it. But go to our YouTube. We need the followers. We need to grow that YouTube channel up for you guys. Thank you so much, Ntabiseng, for that answer. And thank you, Tato, for following us. Really appreciate it. And Bold, thank you for following, as well as Renere. Thank you for following, guys. You guys are awesome and amazing. Dinyiko, thanks for your answers there. Witumelo's got a really good question there. Why did they put PT in the cell notation? Very, very important, right? So remember, when we put that there, nickel is a metal. Metals have delocalized electrons, which means they can conduct electricity. right? But however, hydrogen is going to be a gas, right? Hydrogen will be a gas. It doesn't have delocalized electrons. It can't conduct electricity, but we needed a half cell with hydrogen. So in that case there, what we do is we have a proxy, meaning we will have someone who will then conduct electricity on behalf of hydrogen. So what we normally do there, we choose a metal that doesn't react very easily. So platinum, we know, is an inert metal. Platinum doesn't react very easily. And what it can do is it can do the transferring of electrons on hydrogen's behalf. So platinum is going to be what you put there because the electrode was not made of what we are reacting. The electrode is made of platinum. You must show the electrode on your cell notation. That's a very good question that we do matter. Thank you. Thanks, Lewo and Amu and Mvelo for following. You guys are awesome. And thanks to Juliet for sharing the live. You guys must share the love, man. You guys are great friends to your friends. Okay, let's go and look at the answer of 1.8, right? So 1.8, they're asking you, consider the cell notation for the galvanic cell below. Which one of the following half reactions takes place at the anode of the cell? So one thing that you should know immediately is how we do our half cells. We start off with our, let me zoom in a little bit. We start off with anode, and then we end off with cathode. Right? So already I know that the anode is what's going to be on the left side of my reaction, right? Or you can say you do oxidation and reduction, right? That's another way of looking at this. You can say we do oxidation and we do reduction on our cell notation. So immediately there, I know that it's not going to be A. I know it's not going to be B. Sorry, my screen just froze there. I know it won't be A, I know it won't be B. And then let's look at what happens, right? At the anode, remember, at the anode, oxidation takes place. Oxidation is the loss of electrons. So we know that it can't be C because C shows nickel ions gaining electrons to become nickel metal. That's not what happens at my anode. At my anode is where oxidation happens. Oxidation is the loss of electrons, and there we see nickel metal, right? Losing an electron to become nickel ions. It's a nice and easy one. Anyone who got D there, please give yourselves a round of applause. If you didn't, there's one more question for you to redeem yourselves. Don't panic too much. Okay. Biantle there says, platinum is a good conductor. Well done. It's a good conductor. And most importantly, not just that it's a good conductor, but it's inert. It doesn't react. It won't react in the place of what you're trying to do, which is very, very important. Okay. Okay, there's a question there in the Q&A. Let me quickly address the question. An anonymous attendee, they didn't put their name. Oh, come on, you can put your name. It's nice to get shout outs because I like when people really are engaging. Tata's giving a hand clap there for Team D. Well done to Team D, and thank you to Honeydew for following. All right, so the question there is there any other metal other than platinum that can be used as a metal in place of a non-metal, right? So again, usually when you guys are doing this, the electrodes that you will pick that are going to be slightly less reactive, usually it's going to be platinum that you'll be given for like a lot of the gases. Now and then you'll see them using graphite electrodes, right? Graphite electrodes, graphite is going to be made of carbon basically. So now and then you'll see graphite, but mainly it'll just be platinum. But thank you for that question. I wish I knew your name and then I could give you a shout out for such an awesome question. All right. Cool. Let's go into 1.9, which is in this case is going to be our last question, right? Which one of the following is applicable to an electrolytic cell? Reduction takes place at the anode, oxidation takes place at the cathode, it uses alternating current, or a battery is used for the cell to function. A, B, C, or D. Easiest question of the night. Let's quickly see how quickly we can get our answers in. Thank you for the quick fingers there. There was another question that I did miss out. Sorry, Theo. I don't know who asked the question. We can just give them a quick shout out there. Someone was asking, does this mean that option C would be correct if it was in equilibrium? Wait, does this mean option C would be the correct one if only it was in equilibrium? So again, C would still not be correct if it was in equilibrium, because what we're looking at there for the previous question is what reaction is going to happen at the anode. When you hit equilibrium, it'll still be the same reaction. The difference is that the reactions in reverse will be happening at the same rate, essentially. So the one that's going to be faster would be D. C would at no point be faster. And worst case scenario, it'll be happening at the same rate as D, but not be faster. Thank you for that question. It's a really great one. Tato says Team D again. Let's go. Let's see if you're correct first, Tato, before we can get excited about that one. Okay. But I believe in you guys. You guys have been super awesome tonight. Okay. Last 10 seconds to go. 5, 4, 3, 2, and 1. Awesome. So 1.9, which of the following is applicable to an electrolytic cell? Let's quickly have a look at these ones. Reduction takes place at the anode. Not true, right? It's red cat. Reduction takes place at the cathode. Then B says oxidation takes place at the cathode. Not true. It's anox. Oxidation takes place at the anode. Then C, it uses alternating current. Not true. Electrolytic cells need direct current. They need a constant flow of electrons in one direction. And then D says a battery is used for the cell to function 100%. Yes, it is, because a battery will give you that direct current and everything is going to flow in one direction. Awesome, guys. That's our multiple choice for this section. Now we're going to jump into question 2, right? We're going to do our long questions and then we will take that. So Tato says Team D. D is equivalent to distinction. We're getting them 100%. Tato, I believe in you guys. You're definitely getting those distinctions, guys. It's going to happen. It's going to happen. Awesome. Okay, I'll pause quickly for any questions. And if there's no questions, then I'll jump straight to question 2. If you've just joined us, thank you. Welcome. We just finished our multiple choice. Don't panic. We're here until 8 p.m. So there's still another hour left of the lesson. And then please remember, this week we're attending every day up until Thursday. Yesterday we started with apologies for the guys on TikTok. We didn't go live yesterday. We had our maths paper 2 session. Today is science paper 2. And then tomorrow we're going to finish off maths paper 2. And then Thursday, I'm going to finish off science paper 2. Whatever we don't finish today, I'm going to finish on Thursday. Okay. And then the following week, we're going to go do science paper 1. And then the week after that, which is the week you're writing maths, we're going to do maths paper 1. So make sure you guys are tuned in. You guys are focused for all of these lessons. Mbasa posted in the chat asking, is graphite also a good conductor of electricity? Yes, Mbasa, it is in that case, just because of the structure that it's got. It's not the same as like regular carbon you'd find anywhere else. And then Tato says, sir, please explain that one of C, what equilibrium? I don't understand. So someone asked a question to say for 1.8, they said, if it was at equilibrium, would the answer then be C? So remember with your half reactions, if you go, let's quickly go to our table of reduction potentials, right? Let me go to 4B, because if I go to 4A, someone's going to shout at me. Okay, so let's go to the one with nickel, for example. So on our table of reduction potentials, it's very important to note that these are reversible reactions, right? These are reversible reactions. So what I was saying is that in that case there, your nickel was the stronger reducing agent, right? It's the one that's going to undergo oxidation, the nickel ions. Sorry, wait. The nickel metal was the stronger reducing agent. It's gonna, this one is gonna undergo oxidation in this case here. Now the person's asking, if we get to equilibrium, will the reaction then go the opposite direction? So if we get to equilibrium, are we now gonna go in this direction? And I'm saying, no, we're not gonna go the other direction if we hit equilibrium. Apologies for that. I need to just verify that I'm still here for the Zoom, the TikTok live. Otherwise, it's going to end the live. Okay, so if we hit equilibrium, the rate of, in this case, so initially when the cell is running, our reverse reaction, we do that in red, is the one that's going to have the highest rate. That's why we see nickel getting oxidized to become nickel ions and 2 electrons. Remember that our forward reaction is still happening, just way less than the rate of the reverse reaction. When we get to equilibrium, the person was asking, are we then going to now see the reduction happening? And I'm saying, no, it won't happen. Worst case scenario, they will happen at the same rate. But we won't see a moment where now our reverse reaction supersedes the forward reaction superseding the reverse reaction. At worst case scenario, they'll happen at the same rate, but we won't see it now. All of a sudden, oxidation becoming reduction. Worst thing that'll happen is that basically we will hit equilibrium and our concentrations will just remain constant at that point there. Cool. Thank you for everyone who's sharing the live. Thanks to Mercury for following. Thanks to Kizzy for following as well. You guys are really awesome. Okay, let's jump to our long questions. Okay, we're going to start with question 2. All right. So question 2 looks like this, right? So we have this whole setup here where it says now, oh no, that's the wrong one. Sorry, let's go. Here's question 2. So there's question 2. Question 2 now is set up like this, right? We've got a test tube containing a straight chain organic acid X, right? Ethanol, and the catalyst is heated in a water bath. As illustrated below, so you got a test tube, you got your water bath, you've got your X plus your C2H5OH plus a catalyst. Mbasa's got a hand up. Mbasa, I don't know, Theo, if you can just help Mbasa ask his question there. Remember, guys, academic questions only. Theo, are you there? Okay, let me just... Okay, Mbasa, I've allowed you to talk. You can unmute and ask your question. We're going to give you 5 seconds. If you don't unmute and ask your question, then we're going to move right on. So Mbasa, you've got permission to unmute. You can unmute and ask your question quickly. Otherwise, I'm going to move on.
Sir, I have just a question there in the chat about the carbon rod.
Okay, let me quickly have a look at that question. Okay, the Mbasa.
Yes.
Is graphite also a good conductor of electricity? Then what about the carbon rod, sir? So remember what I said, guys, is that graphite is made of carbon. So when you talk about your carbon rod, that's what we're dealing with. It is the graphite rod. It's one and the same thing. Graphite is just a special name we give to the rod because of the structure it's got. But it definitely is the same thing. If they talk about your carbon rod or your graphite rod, it's the same thing.
Thank you, sir.
And you covered them, Basa. Thank you so much, man. Okay, let's quickly then wrap this one. So we've got organic compound Y is produced according to the following equation. X plus that C2H5OH gives us Y plus H2O. Then 2.1 says, give a reason why the test tube is heated in a water bath instead of directly over a flame. And we've got some quick fingers there already in the group, right? Logical says, alcohol is highly flammable. Rabauna says, because the test tube contains a flammable compound, which is alcohol, so the test tube gets heat equally so. Sarah says alcohol is flammable. Well done, guys. And they were also on TikTok says alcohol is flammable. And that's exactly, it's for safety, right? It's for safety reasons. So number 1, let me quickly go in and say there. It's for safety. Alcohol is flammable. And also what we want to do is want to heat our reaction evenly. Okay, hope that makes sense to everyone there. And then hope you guys are good, right? Another reason as well that you could have given is the fact that you want your reaction to happen before your alcohol evaporates, right? If you heat it directly, what will happen is that you'll have little pockets of heat that will maybe evaporate your alcohol before you could even start your reaction. So it's very important that you use the water bath to heat it evenly, and you heat it nice and slowly in that case there. Okay, let's look at question 2.2. Now, 2.2 says, write down the type of reaction that takes place here. Let's see who can quickly give us that one. What type of reaction is taking place? Remember, the reaction we're referring to is this one up here. What type of reaction is this? Where we've got some kind of acid plus some kind of alcohol giving us some compound Y and water. There says condensation, 100%, and then there we go. Catalysis is esterification, right? Please remember, you're both right. I'd always say give the most detailed answer. So condensation is right. Esterification is a type of condensation reaction, but esterification would be the answer that I would prefer, although you will get marked correctly for condensation. So well done to you guys for that. Esterification is the right answer there. Esterification, you can also just say condensation. Okay. 2.2.2, they said, please give the formula for the catalyst that is needed. Give a formula for the catalyst that is needed. To give you the hint there, let's see if they gave us the hint. Or they just said a catalyst. They didn't say which catalyst, but you guys should know this from your reaction conditions. What is a catalyst that we need for doing this? There's a lot of quick fingers there. Well done, guys. Basa, Justine, too many of you guys came in there. H2SO4, well done there. So we need H2SO4. All right. Okay, that's 2.2.2. Let's move down there. 2.2.3, name the homologous series to which compound Y belongs. Remember, compound Y is one of our products. What is a homologous series that compound Y belongs to? Okay, someone, I just need to make a note, right? I think your name is, it's in a, there's K-Sol. K-Sol, you said sulfuric acid, right? Very important, especially when they highlight things, they make them bold or they write them in capital letters. It said the formula for the catalyst that's needed. If you had written sulfuric acid, they would have not given you the marks. If they say formula, you must give H2SO4, not write sulfuric acid. Very important there, guys. Remember, this is your final exam. Number one, with your final exam, you're not going to get to ask questions about, no, but ma'am, you know what I meant. You're not going to get a chance to go back and ask for your script, right? So don't give the examiner any chance to mark you wrong. Make sure you give the best possible thing. Be meticulous in your answers. Okay, thank you for everyone who's been answering this question really well. And the answer there is going to be the esters, right? Okay, I see there's a question there in the Q&A. Someone's asking, is there any other metal other than platinum that can be used in place of a non-metal? So I think, oh, that's the one that we've already covered. Okay, apologies for that. Okay. And then Butumela says, what about concentrated H2SO4? Again there, Butumelo, the question said, give the formula of the catalyst needed. So you must specify H2SO4. As long as H2SO4 is there, then you're covered, right? That's the most important thing, is that you have it there. And then they was asking, does plural form or singular form matter? In this case, no. The singular and the plural form don't matter, as long as you've got that, which is going to be very important. Okay, let's jump to the next question, which is going to be 2.3. Okay. 2.3 says the molecular mass of compound Y is 144 grams per mole, and its empirical formula is C4H8O. Determine the molecular formula of compound Y.
Ernest.
Hey, Theo.
before you proceed there, Witumelo is asking, what about the, oh, doesn't Witumelo, someone asking, what about the heat?
What about heat? So the
Yes.
question was only asking us for the formula for the catalyst. So that's going to be H2SO4. They didn't, if they had asked what reaction conditions were required, 100%, say concentrated H2SO4, concentrated sulfuric acid plus heat. But in this case here, right, they asked you specifically, when you go back, the formula of the catalyst needed. So if they're looking for the formula, you must give just H2SO4. They didn't say which catalyst is needed or what is required to catalyze our reaction. I see someone also asked, Uratila asked the same question as well. So because they specified formula, the answer that's accepted there is H2SO4. They will not accept anything else. Thank you for that question. And then let's quickly again, 2.3, the molar mass of compound Y is 144 grams per mole, and its empirical formula is C4H8O, right? So what we need to do is try and figure out what the molecular formula is going to be. The first step we need to do is let's find the molecular mass of the empirical formula, right? So the molecular mass of the empirical formula, we're looking at 4 carbons, right? So 4 times carbon plus 8 times hydrogen plus 1 times oxygen. That's going to be 4 times 12 plus 8 times 1 plus 1 times 16. Okay, and then when you've got those together, that gives us 72, right? Grams per mole. But we were told that the molecular mass of compound Y is 144 grams per mole, which means on our side, we know that then the molecular formula is twice as much as the empirical formula, which means we need to just multiply all the numbers in our empirical formula by 2, right? Meaning our final answer is going to basically be, sorry about that. Therefore, we need to then say 2 times C4H8O, which is going to give us C8H16O2. Hope that makes sense, guys. Someone's got a question there. The question is, please may I ask the difference between an empirical formula and a molecular formula? 100%. Yeah, Kizzy even answered you there. Empirical is the simplest ratio of all the elements in your compound, right? So we can see 8, 16, 2. The simplest ratio is if I divide by 2, 4, 8, and 1. Thank you very much, Kizzy there. You're going to be one of our tutors very soon. I can see it. Okay, let's jump to 2.4.
Yeah, Ernest?
Hey, Theo.
There's a question on the Q&A then.
Okay, so it says there, are the calculations compulsory? So what you're going to get marks for in this question here, right? There's a mark for stating that the molecular formula for the empirical is going to be 72. That's, you're going to get a mark. And then you're going to get a mark for the final answer. Those 2 things are the ones that are required. If you didn't show your steps, but you must show that it's going to be 72 for the empirical, meaning it's going to be then double that for the molecular. Hope that makes sense. And then someone asked there, what if the number we got was a decimal? So the number you get can never be a decimal. If it's the true empirical formula, you won't get a decimal. It must always be an integer multiple of the empirical one. You won't get a decimal. It's not like when you are calculating empirical formula. That's different. Here, when they've given you the empirical formula and the molecular mass of the proper one, the answer you'll get will always be a whole number, like a direct whole number. There'll be no decimals. Okay. Thanks, Justine, for that question. It's a really good one. All right. Let's look at 2.4. So 2.4 says, write down the IUPAC name of compound Y. Let's quickly go back and look at what our constituents are, because you guys will need that to write down the name, right? So we've got, in this case here, the alcohol is C2H5OH. Okay, let me put that down here just so that you've got that information, right? So we've got C2H5OH. That is the alcohol. We know that the ester is going to be C8H16O2. So what's the IUPAC name of the compound? Okay, guys, please, I see some of your answers. Please remember what kind of molecule this is, right? Remember what we're dealing with here. This is an ester. Remember how we have to name esters. Okay, some of you guys got it right. I really appreciate it, right? Amange, Tato, Tebuho, well done to you guys there. Thanks, Musa, Neo, Logical. Okay, so because we're gonna have 8 carbons, the alcohol part of our ester is gonna have the YL. The carboxylic side of our ester is gonna have the NO8 name. So we're gonna have 2 carbons and 6 carbons. 2 carbons is gonna be our eth, right? That's gonna be our ethyl, right? And then the other side is going to have 6 carbons. That's hex NO8. Ethyl hexanoate is going to be our final answer. Hope that makes sense to you guys. I'm going to move down to 2.5. Theo, just let me know if there are other questions that I'm not seeing there in the chat. Right?
Ernest,
Yes, Theo.
there's one in the Q&A. It says, what is the answer for 2.2.3?
Okay, let me quickly go back and see. 2.2.3, it was ester or esters.
Okay, thanks, Ernest.
Sure. Okay. Then 2.5 says write down the structural formula for the organic acid X. That should be a nice, easy one. Write down the structural formula for the organic acid X. Remember, we had ethyl hexanoate, so we know we're going to have hexanoic acid, right? So hexanoic acid is the name. They wanted the structural formula. I was just giving you guys a chance to do it on your side, then I'll show you what your answer should look like. Hexanoic acid is going to have 6 carbons. That's 1, 2, 3, 4, 5, 6. And then we know our functional group is going to have double bond O and the OH, and then make sure that you've got enough hydrogens plugged in everywhere else. There we go. That's the structural formula of the organic acid X. Okay. Great. I'm going to move on if there's no further questions to question 3. Hope everyone's happy with how question 2 ended. Okay. So question 3, we've got now here, it says the boiling points of different organic compounds are given below, right? So we've got all of these ones here, HCOOH, we've got CH3COOH, we've got CH3CH2COOH, CH3CH2CH2COOH, and we can see the boiling points keep going up. 3.1 says we need to define the boiling point, right? So to define boiling points, again, definitions are important, guys. There's lots and lots of marks to the definitions. So defining our boiling point is going to be as follows. It's the temperature at which the vapor pressure of a substance equals the atmospheric or the external pressure. Temperature at which? The vapor pressure. Of a substance equals the atmospheric pressure. Okay. Hope that makes sense. That's 3.1. 3.2 says, write down the name of the functional group of these compounds. What is the functional group of these compounds? So let's look at that HCOOH, CH3COOH. What is the functional group of these compounds? You can put that in the chat quickly. Thank you for the quick fingers there from Tato and Bientle and Debuho and all the guys on Zoom. It's the carboxyl group, right? The carboxyl group, that C double bond O with the OH. That's what the carboxyl group looks like. Please don't put this as your answer, what I'm about to draw. I'm just showing you guys so that you are aware. So that C double bond O, OH, that is what we call a carboxyl group. But the correct answer in this case, you must write down carboxyl group. Okay. If there's no questions, I'm going to move on to 3.2.2. They want the IUPAC name of compound C. What is the IUPAC name of compound C? CH3, CH2, COOH. Thank you, Bitumelo, there for your quick fingers. Deborah was asking, is carboxylic acceptable? Right? So again, they do accept it, but let's not give our examiners any chance to get it wrong, right? If you get an examiner who's not super experienced and they were not looking at the marking guidelines correctly, and they were like, no, it says carboxyl, you didn't write carboxyl, they'll mark you wrong. Let's not do that. Mistakes happen in marking all the time. So let's make sure we don't give the examiner that. So yes, they will accept it, but give carboxyl group as the correct answer. Okay. And then for 3.2.2, thank you for all the correct answers there. It's propanoic acid, right? Propanoic acid, because when we count a number of carbons, there's carbon 1, 2, 3. 3 carbons equals prop. Now we've got propanoic acid. Awesome. 3.2.3, they want the structural formula of the functional isomer of compound B. Let's quickly look at what compound B is. Compound B is CH3COOH. I'll write it down here. So compound B is CH3COOH. What is the functional isomer of that compound B? Taryn asks, what is this? I'm not sure what your question is with regards to Taryn. It's a lesson for chemistry, for finals, for grade 12s. There we go. Kizzy responded there. Kizzy, you must let us know if you want to be a tutor. Okay.
Ernest,
Hey, Thea.
there's a question that I just posted there now. It was sent to the panelist.
Okay, let me quickly look for your question. Okay, I think I've found it. Sorry, there was a lot of answers that were coming in. So what is the functional group of the aldehydes? What's it called? The C double bond O. That's called a carbonyl group. So you'll see your aldehydes and your ketones will have the same functional group. there's a carbonyl group, but then it's one is going to be in the middle, one will be at the end. That C double bond O is called a carbonyl group. So instead of carboxyl with an X, it'll be carbonyl with an NYL, carbonyl group. Hope that makes sense to you guys. Okay, let's quickly go through 3.2.3, right? So the structural formula for the functional isomer of compound B. So the functional isomer is going to be ethyl ethanoate, right? Not ethyl, sorry. It's a methyl methanoate. But in this case, they ask for the structural formula, not the name, right? Structural formula, not the name. So the structural formula of that is going to be C. There's only 2 carbons, so you'll have an oxygen in the middle and a C here. The functional isomer of a carboxylic acid is an ester, right? So there's 2 pairs of groups that are functional isomers of each other. So carboxylic acids and esters are functional isomers, as well as aldehydes and ketones. Those are also functional isomers. And then we'll just have our double bond O with a hydrogen and 3 hydrogens this side. Hope that makes sense. The structural formula, don't write methyl methanoate. They're going to mark you wrong. What they wanted you to give was the structural formula to actually give it down. Okay, let's quickly see if there's any questions before we move on to the next question. Okay. Phineas asked if esters have a chain isomer. That's a very interesting question, Phineas. Because normally when we refer to chain isomers, you're talking about, like, for example, butane and methyl propane, right? But the chain lengths are going to be slightly different. I don't know if it, I don't know if it counts. If, for example, let's say we had methyl propanoate versus propyl methanoate. Would that be a chain isomer within an ester? Possibly. I'll try look it up and see. That's a very interesting question. I love this group today. You guys are keeping me on my toes. I love the questions you guys are bringing. Okay. Then Noah asks, isn't the functional group of aldehydes the formal? I'll check. I know I'll check. I might have made a mistake. Noah, I'll double check that there. Okay. And then Oratila says the thing is that we can't draw. I understand. Sorry. I know you guys are giving me the answer because you can't draw it for us, but I just wanted to make sure that you guys understand when you do the answer, it must be a structural formula. Okay. And so the functional group for aldehydes is formal, carbonyl group is for esters and ketones. Sorry, that was my mistake. Sorry, thanks for picking it up there, guys. Apologies for that. That was my mistake. It is, yeah, the formal group. Sorry about that. Okay, and then, okay, let's quickly go in there. Someone's asking, when are you going to do Pure Maths grade 10 revision? We might do that in maybe like 2 weeks' time. For now, we're finishing off the grade 12. Then we're going to have a grade 11 series coming up, I think in the next, if not next week, somewhere very soon. We have a grade 11 series coming up. And then Bianca says, yeah, we just wrote the IUPAC names because we can't draw. 100%, guys. Yeah, thank you for that one there. Okay. 3.3, which one of the compounds A or B or C has the highest vapor pressure? Refer to the data in the table given. So which one has got the highest vapor pressure? I'll go back to the table so you can see it. A, B, or C, which will have the highest vapor pressure? Okay, I think a lot of you guys have got it there. The answer is going to be A, right? Because it has the lowest boiling point. Remember, the boiling point is the temperature at which the vapor pressure is equal to the atmospheric pressure. So the lower the boiling point, the lower that particular vapor pressure is going to be. So A is going to be our answer for that one, because it has the lowest boiling point, or even the shortest chain length as well, right? The weakest intermolecular forces in total. So it's going to be A, right? Your reason is that it's going to have the lowest boiling point. BP and the weakest intermolecular forces. Okay. 3.4, the boiling point of compound B is now compared with compound X, right? So we've got compound B and compound X, and we're comparing their boiling points. Besides the conditions used to determine boiling points, give a reason why this is a fair comparison. So besides the conditions used to determine boiling points, give a reason why this is a fair comparison. Someone's answering 3.4.2 without having answered 3.4.1. Martin's asking same time tomorrow. Yes, Martin, same time tomorrow, 6 p.m. to 8 p.m. Debuho's got that run there. They have the same molecular size, right? Same molecular size, same molecular mass. So these two compounds have the same molecular mass. Therefore, it's going to be relatively a fair comparison, right? So they have the same molecular mass or molecular size. Okay, 3.4.2, the one you guys have been eager to do, is compound X primary, secondary, or tertiary alcohol? Give a reason for your answer. Primary alcohol, you guys are right. Remember, you should always give a reason, right, for your answers. So it's going to be primary. And the reason is you can say the hydroxyl group is at the end of my chain, or you can say, well, more correctly actually than that, because it could be at the end of your chain with a methyl group, which would then make it secondary. So don't say that. So rather say that the carbon it's bonded to has a bond with only one other carbon, right? So our OH is bonded to a carbon that is bonded to one other carbon atom. Okay, hope that makes sense to you guys there. We're gonna jump then on to the next question. 3.4.3. Fully explain the difference between the boiling points by referring to types of intermolecular forces present in each of these compounds, right? So we need to look at why they have different boiling points as we look at these compounds. There's 4 marks to be gained, and let's see how we can then basically get those 4 marks. Now, again, I think we're still dealing with B and X here, right? So let's look at B and X. So B and X, B is our carboxylic acid, X is going to be our alcohol, right? So in both these cases here, right, there are gonna, both these compounds will have dipole, as well as London forces basically in your hydrogen bonding involved. So they will both have those in that space there. Now, another thing to note is that compound X only has one site for hydrogen bonding, right? And compound B has two more sites for hydrogen bonding, which is important. That's why compound B would have a higher boiling point in that case there. The intermolecular forces in compound B are going to be stronger than those in compound X for that reason, which is going to be important. And those are basically points that will help you get your marks and help you get those answers, right? So let's quickly go and put those notes down. I'm going to write it in shorthand just to save time, okay? So both will have dipole and hydrogen bonding. Okay. Another thing to note in this case here is that B, I think it was B. Yes, B has got the higher boiling point, right? B will have more hydrogen bonding sites than X, right? And as a result, it means that B will have stronger intermolecular forces. Than X. Okay, very important to note that when we are going through this. That's question 3. I'll pause to see if there's any questions for us to go through. Someone said repeat 3.4.1, and someone says, what about more energy will be needed to overcome the intermolecular forces? 100%. Sorry, 2 seconds, guys. Apologies for that sneeze. Yeah, so the stronger intermolecular forces mean more energy is required to overcome them, and that leads to the higher boiling point, right? Intermolecular forces. Okay. Someone's asking there, what about surface area and the chain? So again, definitely it's going to be a big one. It's going to be less of a factor, right, than the hydrogen bonding. The hydrogen bonding is going to be a way bigger factor than the length of those chains, because, you know, 2 carbons versus 3 carbons, when it comes to the London forces of those, it doesn't make as big a difference as twice the number of hydrogen bonding sites. But it is a factor. It's just going to be a very slight factor though. But you are right. You can definitely put that in your answer as well, that the one has more, but the hydrogen bonding will definitely be higher. So you can see like X has got more carbons, right? But B will still have a higher boiling point. B has less of a chain length, but it has a higher boiling point just because that hydrogen bonding is way stronger than the London forces that X is going to have. So that's going to be very important as well. Okay. Okay, let's quickly see if I've been missing out on TikTok questions. Again, another question they're asking about not explaining the chain length. It's because the chain length isn't gonna help me with the one that's got the longer chain. It's got the lower boiling point because it's less of a factor than the hydrogen bonding. That's why I didn't talk about the chain length. Let me see. Yeah, everyone, yeah, the comments have just been good, decent there. All right. So isn't the dipole for aldehyde and ketones only? This is a question from Tlori. So Tlori, please remember, right? Hydrogen bonding is dipole-dipole. It's just a special case of dipole-dipole, right? It's the special, it's like the strongest type of dipole-dipole. When you've got now, like, hydrogen bonded to atoms of very high electronegativity that are quite small in size, right? That they end up forming really strong bonds, and they must have at least one lone pair. That's big. That's important. So usually hydrogen bonded to nitrogen, oxygen, or fluorine will give you hydrogen bonding. Those are still dipole-dipole bonds because you're dealing with a dipole. Just that it's a very strong type of dipole-dipole. It isn't something completely different. So whereas your aldehydes and ketones have dipole-dipole that is not hydrogen bonding, alcohols, carboxylic acids are going to have your dipole-dipole that is hydrogen bonding. Okay, hope that makes sense there. Or dipole-dipole that's capable of hydrogen bonding, if I can call it that there. Hope that makes sense to you guys. Okay, and that's the end of question 3. We're going to jump over to question 4, and hopefully I can finish question 4 today, and then at least maybe tomorrow we can start with question 5, right? Okay. Question 4 says, we've got 3 reactions of organic compounds from the same homologous series. They're shown below. So reaction 1, butane plus Br2 becomes 2-bromobutane plus P. Reaction 2, pentane plus excess oxygen and heat gives us something. Reaction 3, hexane becomes C2H4 plus Q. And then they ask us to define homologous series, right? So in defining homologous series, it's going to be a series of organic compounds that can be described by the same general formula or functional group, right? So a series of organic compounds that can be described by the same general formula or functional group. Okay, hope that makes sense to you guys. Let's move on to 4.1.2. 4.1.2 asks, name the type of reaction represented by 1. So we start with butane plus bromine, giving us 2-bromobutane plus P. Okay, so I'm seeing answers there. Only 2 of which I see as correct. A lot of people are saying addition. Please look at the molecules before and after, right? What is the state of saturation of my reactants and my products? Very important. A lot of people are saying addition. And if it's addition, right, addition requires that we start with an unsaturated molecule and end with a saturated molecule. In this case, I've got butane saturated and bromobutane saturated. Saturated to saturated means we're going to be dealing with substitution. Very, very important, right? Okay, they will also allow you to say halogenation or bromination, but usually halogenation is when you're talking about addition reactions. So again, like I'll tell you guys, they'll accept it, but remember, it's going to be that one examiner who's really good and meticulous. Your paper could be on the last day of marking, and the people are exhausted and they're very tired. You don't want to give them a chance to mark you wrong. So substitution will be there. They will also accept halogenation. They will also accept bromination. Okay. Let's jump down to 4.1.3. Theo, please just give me a shout if there are other questions, and then otherwise I'm going to just move on. 4.1.3 says, write down the formula of the inorganic compound P. Inorganic compound P is a product of reaction 1. Butane plus Br2 will give us 2-bromobutane. Thank you, Tato there. Thanks, Ravana, as well as Bitumelo. HBr is the correct answer.
There's a hand in it.
Okay, Sarah, your hand is up. We're gonna allow you to unmute and speak. Theo, if you can help with that. Please remember, academic questions only. Sarah, we're going to give you 5 seconds to answer your question, to ask your question. If you don't ask your question, we are then on our side going to mute you. Okay, Theo, if Sarah's not unmuting, I'm going to continue on my side.
Unmute. I'm not so sure. It was the connectivity. I can't hear anything though.
Sarah, are you there? Sorry, I thought there's something wrong with my screen share. I'm going to just stop it and restart it again. There's a little gray block that's I can't remove.
I see it on the bottom right there.
Yeah, let me just try to do this again. Okay, Sarah, I'm just giving you enough time until I'm done with my screen share again. Okay, Theo, is it back?
Yes, it's fine, Ernest.
Okay. Just want to check something. Okay, there we go. Okay. Is that on your side or is that Sarah's side?
Sarah's side, Ernest.
Okay, Sarah, we're going to mute you and continue on our side. Awesome. So let's look at 4.1.4. On our side here. So 4.1.4 says, give the structural formula of the positional isomer of 2-bromobutane. Four point 1.4. Okay. You guys can post the name of it. Thank you so much for Tato there and Tebuho. You guys are doing really well. And with Tumela and Mokadi and everyone else. Here's a quick question and bonus points for this person, right? Why can I not give 3-bromobutane or 4-bromobutane as an answer? Here's a question for you. Why can I not say 3-bromobutane or 4-bromobutane as an answer? If you're on Zoom and you'd like to answer like verbally, you just put a hand up. We'll let you speak. While you guys think of that, I'm going to draw the structural formula of 2-bromobutane. So we're going to have 1, 2, 3, 4 with our bromine there, hydrogens everywhere else. There we go. Bianca says still would be position 2. Tutlechang says it would still be 2-bromobutane if we change our counting. I don't know if it makes sense. No, it definitely makes sense. And then people are coming there. There are only 4 carbon atoms, so the only possible positions are 1 and 2 because the substituents need to be the closest when we count, right? Well done, guys. So basically, I can't have 1, 2, 3, 4, right? Bromobutane in this case there. So this is like I can't have it like that because that means I didn't start counting from the carbon closest to my functional group. It means my counting wasn't correct. My counting was supposed to then be, oops, sorry, it wasn't meant to do that. My counting was wrong. This is always going to be carbon number 1, 2, 3, and 4. Hope that makes sense to you guys. Let's do now the functional isomer should basically look like this. And then here you will have your H and your BR. This is the answer that you guys are looking for in that case there when you are looking at it. Okay, hope that makes sense to you guys. 4.1.5, using molecular formulae, write down the balanced equation. Section 2. Hey, Theo.
Let's check the chat.
Okay, give me 2 seconds. A very humble request, sir. Question 4 is where I lost a lot of marks. This is because I find it difficult to memorize all the 13 organic reactions and their requirements. Can you please give me advice on how to approach these questions and how to maybe know all of them, please? I don't want to disturb the lesson. You'll answer me at the last minute of the session. This is not you disturbing the lesson at all, right? This is exactly what we're here for. So I'll try and find a way to share this. So there's a diagram that we have that basically looks at it. So for me, thinking about all 13 organic reactions, there's not 13 organic reactions, right? For me, there's 3 types of reactions: addition, elimination, substitution. What you need to remember are all the different reaction conditions. That, unfortunately, you have to just try and memorize. But don't think there's 13. There's 3: addition, elimination, substitution. And then you need to just look at what takes place for me to then do that. What will help you? Just try check on our YouTube. We did a lesson on organic chemistry and organic reactions, and then you'll see we'll go through all of it there. But I'll try give a quick overview of it at the end of this lesson. But thank you for that question, right? Okay, let's quickly go back to 4.1.5. 4.1.5 says, using molecular formulae, write down the balanced equation for reaction 2, or we're going up to reaction 2. Reaction 2 is pentane plus excess oxygen, giving us something else, right? So molecular formula of that there, pentane is going to be a hydrocarbon with 5 carbons. So that's going to be C5H10 plus 2, which is 12, plus excess oxygen, which is going to be O2. And this is going to be in the presence of heat. This is a combustion reaction. Combustion reactions will give us, as products, carbon dioxide plus water. And then if you go and you balance your reaction, what you'll find is that you need 8 oxygens, and then you need 5 carbon dioxide, and you need 6 water to have this reaction balanced, right? They did specifically ask for the balanced equation. You must put that in there. It is quite important. All right. Then it says reaction 3 is an example of a cracking reaction. Define cracking. Right? Cracking, quite easy. It's a chemical process in which longer chain hydrocarbons, right? Or long chain alkanes are broken down into shorter, more useful hydrocarbons really for us at the end of the day. They could be alkanes, they could be alkenes. So in short, I'll quickly put there. So it's a process where long chain hydrocarbons are broken down into shorter molecules. Could be alkanes, could be alkenes in the process. You'll get your marks there. Okay. This 4.1.5 is not balanced. Please just recheck the answer. Let's have a look at that quickly. So my carbons, I've got 5 carbons on this side. I've got 5 carbons on this side. My oxygens, I've got 8 times 2, which is 16. My oxygens on this side, I've got 5 times 2, which is 10, plus 6 times 1, which is 16. And then my hydrogens, I'm going to have 12 on the left-hand side. Hydrogen 6 times 12. That looks very balanced to me. Oratile, maybe just check your working out. Yeah. Okay. Thanks for that. Okay, I'm glad you saw your mistake. All right. Okay, then 4.1.7 says, give the structural formula for organic compound Q. Let's quickly go back and see what is organic compound Q. Organic compound Q, we've got hexane giving us C2H4 plus Q, right? Hexane gives us C2H4 plus Q. So this is an example of that cracking that they were referring to. So let's see how we can basically work our way to the answer of what that's going to be. I'll just rewrite that reaction down at the bottom again. So hexane is going to be C6H14, right? And hexane breaks down into C2H4 plus Q. I want you guys to tell me what is compound Q. Thank you for quick fingers there on TikTok. Okay, and the guys are great there. So again, we've got compound Q being C4H10, right? Butane. But again, remember, they wanted the structural formula, so we have to draw it out. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Hope everyone's happy with that there. And then if so, I can move on. Okay. Yeah, someone said butene, not butene. If you would have butene, you'd be missing some hydrogens in that case there. So it's definitely butane, not butene. But thank you guys all so much for the answers you've been giving. And then 4.2, we're almost done, guys. Study the flow diagram below. 2-bromobutane undergoes hydrolysis to give us compound R, and then compound R undergoes another process to give us an alkene. Write down the IUPAC name of compound R. 2-bromobutane undergoes hydrolysis. What is the IUPAC name of compound R? Remember what hydrolysis is, right? It's your substitution reaction involving your water. Thank you so much for the great answers there. Very important IUPAC name, you must give the full one, right? So it was a 2-bromobutane, that substitution, the OH is going to land up in the same position, right, as the bromine. So you should end up with, as an answer, 2-butanol. Right? Or you can write it as butan-2-ol. Like that. Okay. Okay, hope you guys are good with this one there. Let's do the last question for tonight, and that's 4.2.2. Compound R reacts in the presence of concentrated phosphoric acid to form an alkene, right? Write down the structural formula of the major product of this reaction. the major product of this reaction, right? Very important there. When you hear major product, you must think Markovnikov's rule, you must think Zaitsev's rule, right? Those rules basically tell you that when undergoing addition reactions and elimination reactions, you give hydrogen to the carbon with the most hydrogens, you take hydrogen away from carbon with the least number of hydrogens, right? So let's try and have a look at what's going to happen there. So we start off with compound R was 2-butanol. Let's first draw compound R, and then we can quickly see how this is going to go through. So compound R is going to be 2-butanol. That's 1, 2, 3, 4 with OH there. There, okay. So we need to now undergo an elimination reaction, right? In the elimination reaction, one of the things that's going to get eliminated, we know, is this OH. But the question is, are we going to take the H on the left or on the right? Remember, with, again, the major product means that we must take the hydrogen from the carbon with the least hydrogens. Carbon 1 is going to have 3 hydrogens. Carbon 2 has 2 hydrogens. So we must take this H away. So we're going to then take this H basically, and that's going to give us an H2O there. And then when we've taken that away, it's going to form a double bond in this case here. So that's what you need to end up with at the end of the day, with your double bond in between carbon number 2 and carbon number 3. Very important, guys. Okay, if you had a double bond between carbon 1 and carbon 2, that would have been your minor product, not the major product. Hope that makes sense to everyone. And that's the end of our session today, guys. I hope that makes some level of sense. The person who was asking about that organic chemistry question, please go to the YouTube and then find the video where we go through the organic chemistry, the organic reactions especially. It'll help you quite a bit when you go through that. So please definitely go through that, and then you'll find it quite useful. Okay, I'll pause to see if there's any other questions. Ravana's asking, would I be wrong if I also add water to the major product, right? So they specifically said the major product in this reaction is going to be that butene, right? I think if you wrote plus water, I don't know if they would mark you down. The marking guidelines doesn't say anything about taking marks away. They will take down marks, maybe, for example, if you had the right functional group, but you had the double bond in the wrong place. Sorry about that. But then, yeah, in this case, the major product is going to basically be your 2-butene. That's going to be your major product. Hope that makes sense for that, Rabana. Then on TikTok, Tato says, thank you a lot. No, thank you, Tato. I really appreciate you guys for being here the whole session. What time do we start tomorrow? 6 p.m. So this whole week up until Thursday, 6 to 8 p.m. is how we'll be running. Okay. Jenny says, what time does the session start? 6 to 8 p.m. Thank you for sharing the live. How do we write an investigative question? In this case there, it's going to really depend on the investigation. So I think in that case, it might be a bit tricky. If you want help with that, listen, go to our website, go to the learningspace.co.za, and you can maybe book a session with a tutor. If you're not already part of like a Flow Institute program, just go to our website, book a session with a tutor, and then they'll be able to help you there. We do run great specials sometimes, and you can sometimes even be lucky and score yourself a free lesson. So just go there and double check, and then someone will be able to help you. But thank you guys so much for being an awesome group. Let me quickly look on Zoom. Okay, so can you tell me which year's paper this is? I'll tell you which year's paper it is at the end of paper 2. So we're going to finish this paper off on Thursday. Then I'll tell you which paper it is to go. I won't tell you now because I don't want you guys to go and look for all the answers and look for everything. So it's important that we just take the process through together. In the meantime, just go and practice. Go practice papers from the last couple of years. I'll give you in that case there. Someone asked there, how do we view you live on TikTok? well, you're on Zoom, you get the best version because you can speak when you're on Zoom. But on TikTok, go to our TikTok page, the Learning Space ZA, and then you can just go watch the live on there. Just that the problem is on TikTok, you can only type, you can't speak. Logical says, thank you for the lesson. Till then, have a good night, sir. And to everyone else, fire emojis. Fire emojis around. Thank you so much, Logical. I appreciate you guys, man. You guys have been really awesome. You guys have been great. Let's enjoy the rest of our evening. If there's no further questions, I'll hang around for another 5 minutes to see if there's questions on what we've just finished. If not, guys, have an awesome evening. I'll release you guys. Have a great one. Okay, please post questions if you got. Jenny posts there, follow and set your notifications on, then you won't miss a live. 100%. I'm gonna start saying that as well. Sitle says chemistry, ne? No, don't worry, Sitle. Chemistry is not that bad. We're gonna help you nail chemistry, right? So don't come with a negative attitude. If you come and you're gonna just have a smile and a good attitude, it is gonna end well for you. Thank you, Akwana, for following us. We really do appreciate it. Okay. Someone asked about repeating the part about booking a part of the tutor. So if you probably at a institute school, you might have a tutor already at your school. If you don't, I was saying to the guys, especially on TikTok, to be able to just go to the website and do that there. So in our case, if you I'm trying to think of an easy way to do this. I think what I'll do is I'll speak to the team and see in what way, if you go to a school that's sponsored by the institute, and so basically if you're on Zoom, that's probably where you are. We'll try and speak to the team and see how we can try and make sessions that will help you guys, try and get you guys online tutors in the meantime. So I know depending on the school that you're at, some schools we've just started with you guys, so we haven't gotten to the point of placing tutors in your schools yet. We're going to have tutors in your schools by next year, but for now we don't. We'll try and see how we can maybe help you online in the meantime. Okay. Thanks, Diamond, for following. Someone's asking, what is the major product? Right. And then again, Mbasa's asking, what's the difference between the major product and the minor product? Okay, I'll quickly repeat that. That's a really good question, right? So what we're looking at there. So what we're looking at, Theo, just confirm that you can still see my screen. Yeah?
Yes, I can.
Okay, let me add a blank page here. Okay, so what you've got there, I'll explain it like I did before. Let me copy this. Okay, so we had this in the previous question, right? So let's say what it was, we had 2-bromobutane. Now, we want to undergo an elimination reaction. So when we eliminate, we know definitely that bromine is going to go, right? But now, I need to take something else. Am I going to take the hydrogen to my right or the hydrogen to my left? Now, there's a particular rule. You'll have Markovnikov's rule and you'll have Zaitsev's rule, right? Those are going to be for addition and elimination reactions. So your major product is one that follows Markovnikov and Zaitsev's rules. Those are your major products. If they don't follow that rule, then you end up with a minor product. So in this case here, if I undergo an elimination reaction, remember, take hydrogen from the carbon with the most hydrogens, give hydrogen to the carbon with the least, you give hydrogen to the carbon with the most hydrogens. You take hydrogen from the carbon with the least hydrogens. So in this case here, I need to take a hydrogen. Carbon number 1 has 3 hydrogens. Carbon 3 has 2 hydrogens. So I will take from the one that's got the least, right? That's carbon 3. So I'm going to take this hydrogen here, and that means I will end up with a major product. So the major product of this reaction is going to be C-C double bond C-C. Let's assume all our other hydrogens are going to be there. Okay, right. This is now my major product. But, right, what could have happened here is I could have decided instead to take the hydrogen here on the left. If I had taken the hydrogen here on the left, I am not following the rule that I need to follow, right? Now, in that case there, if I don't follow the rule, that's going to end up with me sitting with the minor product. And then the minor product is going to look like this. Let me quickly take this off here. So if I had taken the hydrogen from the first carbon, what I would have ended up with there is the double bond would have been gone. And I would have had the double bond here, right? In which case I'd have to remove one of these hydrogens, and then, yeah, that would be covered. And this here would be my minor product, the one that does not follow Markov-Nikov and Zaitsev's rule in that case there. Hope that makes sense to you guys. And someone asked there, in cell reactions, how do I know which one is the anode or the cathode? Don't worry, on Thursday when we finish off this topic, we're going to remember, on this paper, I will do every single topic, guys. So on Thursday, we're going to do the topic that covers electrochemistry. I hope that goes well. Someone's asking on TikTok, are we going live tomorrow? Yes, we are, 6 p.m. to 8 p.m. That's what we're going to do. Okay. Guys, you guys have been really, 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 really awesome. Will you always be tutoring us until the end of exams? So this program is going to run, I think we've got 3 weeks, running up until we get to your finals, right? We're going to be literally up until the day before you write math paper 1. And then what we'll do, we'll see, man. If there's more sessions that you guys will find useful, we can have a talk and see if there's guys on the team that have the energy to keep going. We've had a really, really hectic year so far, but we're going to try and do everything for you guys to make sure you guys are able to pass and nail those distinctions, guys. So yeah, from my side, I really appreciate it. From Team Go Institute, Team Learning Space, man, we think you guys are awesome. We'll see you guys tomorrow, 6 p.m., where you'll be joining Tabang for him finishing off maths paper 2. I think that's going to be a really awesome lesson. Make sure you join that. He's a great maths tutor.